Hello, in this video I will demonstrate how to find the extreme points of a feasible region associated with a linear programming problem. So let's get started. So the example problem that I have selected is stated up here. It has two variables and three constraints plus the two non-negativity constraints. We want to maximize z equal to 5x plus 4y, subject to the first constraint r1, y less than or equal to 10, r2, x plus y less than or equal to 20, and r3, x minus y less than or equal to 10. I have already plotted the feasible region in this area here, identified the feasible region with the red border lines. Our feasible region has 5 extreme points as identified here in this graph. In case you're wondering about how to plot the feasible region, please watch my video on how to solve a linear programming problem using the graphical method. In this video, I will demonstrate how to identify these 5 extreme points. Okay, let's start by identifying the first one. The very first one is the origin here. Obviously x is equal to 0 and y is equal to 0. So that's our extreme point number 1. Let's call it number 1. We go to the second extreme point, number 2. In this case, we can see that y is equal to 0. Even though you can see that x is equal to 10, I'm still going to demonstrate how to actually get that point. Remember, this is the x-axis, which is y equal to 0. And this is the third constraint, which is x minus y less than or equal to 10. But when we want to find the extreme points, we have to make it an equality. So this is going to be extreme point number 2. As I said, in this case, y is equal to 0. And then we make the third constraint an equality constraint. So in this case, it will be x minus y equal to 10. And then we substitute y equal to 0 in order to obtain the value of x, which in this case x will equal to 10. Therefore, our extreme point number 2 is going to be 10 and 0. Now we will go ahead and try to find the extreme point coordinates for number 3. We can see that number 3 is obtained by intersecting R3 and R2. So let's do that. This is going to be extreme point number 3. First, we make these two constraints equality. R3 is equal to x minus y equal to 10, and then R2 is equal to x plus y equal to 20. In this case, we are going to solve for one of the variables, substitute into the equation, and then find the other one. Alternatively, you can just add these two equations and you can see that y gets eliminated. But just in case, let's say we take the first one and we find that x is equal to y plus 10, which we then substitute into the second equation. So that will be y plus 10, which is x, plus y is equal to 20. and then we simplify the result, so there will be 2y, and we take 10 to the other side, it will be 20 minus 10, which is equal to 10, and that would give us the value of y equal to 5. We now take the value of y equal to 5 and put it in the first equation or the second equation, it doesn't matter. So it will be x minus 5 in the first one equal to 10, and then we take 5 to the other side, that will give us x equal to 10 plus 5, which is equal to 15, and that gives us the value of x equal to 15 and y equal to 5, and that's our third extreme point. The third extreme point is 15 and 5, which you can see it makes sense. It's about 15 here for x and 5 here for y. We can now move on to finding the coordinates of the fourth extreme point. We see that the fourth extreme point is obtained by intersecting R1 and R2. So let's do that. This is extreme point number 4. So again, R1 is y equal to 10, and R2 is x plus y equal to 20. So we substitute y equal to 10 into the second equation, so that will be x plus 10 is equal to 20, and we take to the x 10 to the other side, and that will be x equal to 20 minus 10, which is equal to 10, and that's the value of x and that's the value of y. So our fourth extreme point will be 10 and 10. Finally, we want to solve for the fifth extreme point. Well, that's the y-axis where x is equal to 0, and this is the intersection of x-axis, y-axis and R1, where y is equal to 10, and obviously the fifth extreme point is going to be 0 and 10. And that's how we find the extreme points of a feasible region.